Okay, we're shifting back to AI and blockchain synergies. So big tech strangles the growth of innovation in AI by restricting the supply of training data and AI hardware. And in this talk, James will illustrate how Web3 can actually decentralize access to high-quality verified training data and GPUs. And the title of the talk is Demolishing AI Gatekeepers.
Thank you very much. Demolishing the AI. So obviously I wanted to do this talk. We're at a data science conference, but obviously I wanted to keep it within crypto. I'm from Superchain. We're basically focused on getting and there we go. So I'm not going to talk about the depths of AI. I think I can assume that everybody here understands like what AI is and how powerful it is. AI is really the next horseless cart, which is basically the next car, the next industrial revolution. So we all know this, and I'm going to assume that we all know how that can be possible. But we're currently limited in a lot of different ways by gatekeepers. So gatekeepers come in various forms, but really what this means is who is restricting access to the tools that we need as AI practitioners to progress, to train new models, to learn. And I'm going to talk now about what those gatekeepers look like and how we can break them down and understand them. So in terms of data, we have walled gardens. So we have companies that are making money from storing user behavioral data, understanding of data. And I know that you guys probably already know this, but here's, the kind of value that is locked into these businesses through monopolistic practices like invading privacy, storing data, keeping it to themselves, etc. Now, that really comes to a lack of data ownership for individuals, where your data is being given away, stored, because you use free services, they're then used for advertising, etc. And you can see in this chart how much value you're giving away as users of these platforms. The other limiting factor, which is really important, is compute. Cloud computing companies, they basically control who is allowed to train large-scale models. You need to negotiate. They have quotas. We have actually run into this problem where we're trying to get more GPUs, right? You can't just go get them like that. You need to do deals. You need to sit down. It's not just this click a button, put your credit card in. If you've got the money, you're good to go. These are constrained resources. NVIDIA actually has a startup program that basically means that you get to raise money from venture capital if you're on this program, because the VCs know you can actually spend their money to train this model. If you don't have that, you're now limited to 10 GPUs, something like that. So the scope and complexity of the machine learning or AI systems that you want to build are severely limited. And if you do want to access the latest and greatest generation of things like GPTs, they're very much restricted. So at the moment, the primary OpenAI is the company that is basically primarily controlling the top LLMs. And they have an API which is very well controlled. You can do some training with it, you can do some fine-tuning with it, and that's really great. But they then, once you start using these platforms, once you start using these APIs, you get addicted to them. They do things like this marketplace idea, where they basically destroyed a whole host, hundreds of startups, like instantly, because when you use their APIs, you're betraying what you're doing, how you're doing it, what your business model is. So for example, like there was lots of PDF, Reader, Explorer startups built on top of ChatGPT, which have now been replicated, and you can just use ChatGPT. You don't need any of these startups anymore, so their business models were destroyed. So in that case, it's not really ideal for startups to start taking like large amounts of risk where they're fully dependent on a centralized platform's whim of the day. And as we've just seen, changes in leadership apparently can happen instantly, and that obviously massively affects the direction of those companies, the services they provide, and whether your company, as someone who's doing machine learning AI, is going to exist tomorrow. The other third issue, which I think is a really important one, is that talent is very scarce in AI. So the top talent is being fought over by basically these big tech companies. And this is actually why this shakeup of OpenAI has been a huge opportunity for Microsoft to acquire these people. They were previously offering about $10 million signing bonuses to move between one company to the other. So if you're a startup that can offer $10 million signing bonuses, I'd like to talk to you to find out how you raise that much money. But it's a very difficult thing. And there's a very limited supply with a very long lead time. So that means, you need a PhD, you need to have studied a long time, you need to be smart. You're basically looking at 1% of the population. I think Serbia is producing maybe 100 of these people a year, other countries more, but still not that many. So big companies actually do a lot of acqui-hiring in this area. They acquire startups purely for the talent. So you end up kind of very constrained in terms of hiring. Maybe in your startup, you're going to have one person that really gets the AI, ML stuff, and then you're going to be relying on them to push you forwards and hope they don't look at LinkedIn too much. So together, this is the holy trinity of what's kind of being gate-kept, and that's data, compute, and talent. Data, basically by walled gardens, keeping things private. This used to be your data, but not anymore. Compute, which is through companies like NVIDIA, cloud service providers, etc., restricting access to these platforms or forcing you into kind of unpleasant negotiations. And the last one is talent. So this is being able to actually bring on the people that you need to go build your platform, build your AI. So do you want to be stuck riding a horse? Or do you want a horseless carriage? I know which one I'd want. So what can we do about it? So what we believe is that we can connect blockchains with AI. So this is a great buzzword presentation, but I'm going to tell you a vision for how we can actually do it and how value can be extracted with a real use case instead of just saying how amazing blockchain and cryptos are in the hope that the numbers go up. The first way is through unconstrained ownership. So this is a way of exploiting the properties of blockchain, like that they're trustless, they provide verifiable and transparent data, and that basically it's always clean data. So what does this mean? This means that we can build completely trustless systems on top of blockchains. You don't need to make an assumption that the API you're calling or the bank statement that you're learning from is correct. You know it's correct because that action has taken place on the blockchain and it is instantly settled. So you cannot make the kind of assumptions and other strange errors that can happen in ML data sets because it comes out basically clean. In terms of the other properties, we have these trustless and verifiable data properties. And this is basically where, instead of you needing to trust a central party, you can trust the blockchain itself and the rules of that system to basically give you that data, and you can know that no one has fiddled with that or messed with that in any way. And this is something that at Superchain we focus on, is making this process very easy while maintaining these trust assumptions. I wanted to talk about one use case because I think it's really important, and crypto people are very naughty at selling to each other and not selling to the rest of the real world. So I wanted to talk about decentralized physical infrastructure, or DePIN. And this is a relatively new term which is yet to be fully formed in terms of vision. But what it means is that if you take IoT sensors, take GPS, pollution sensors, or other examples, the one on the right there you can see is a selection of different pollution sensors. You can create verifiable real-world data. For example, you could place pollution sensors all around Belgrade, you could write those to chain, sign from each one of those, and reward those people for running those sensors. That would be a really important step in producing an open, verifiable data set for what the actual pollution levels are in Belgrade throughout the year at any time on a kind of road-by-road basis. You could also look at this for things like supply chain management, RFID, all these different things. I think it's a really promising area. It's not there yet, you can't use this today, but it's starting to come together. But I wanted to make an example of it because once you can start bringing sensor data into the realm of blockchain, you can start using it to make decisions. So, as an example, if you're an insurer, what do you need to know to, say, insure something? You need to know the state of it, what's happening. So, for example, you can get insurance payouts if the weather is particularly bad this year, if you have a farm. So on a farm, you're going to be affected massively by a storm, etc. So you can need a payout of that. These kind of verified sensors could give you the ability to say, yes, today it was raining, right? And it's rained this much. And we've got 50 people that agree and say that's the case. And by doing things like that, we can start to build more complex financial infrastructure around real-world problems and provide that insurance liquidity from potentially other users. So us in the room could choose to backstop this type of insurance. And that's extremely powerful because now you're disintermediating the process. That basically means to take the middlemen out of the process, which are rent seekers. And those people are basically taking value away from you and taking their cut off the top. The closer we can bring these things together, the more efficient the market we can create, which means the better insurance, the more stuff we can do, the bigger farms we can run, etc. So on the side of compute, there's a few different options available. There's a very cool company called Jensen that are building a few different things, but you can break down the restrictions that are stopping us decentralizing kind of into three key parts. So one is, how do you access the actual hardware? So GPUs, tensor processing units, etc., are available, and a lot of gamers have them, and obviously what were the previous Ethereum miners also have a ton of GPUs available to them. So this hardware exists, it's out there. It is mostly at the consumer level, although there are some like A100s out there if people need to run larger models. Building a permissionless system around this is going to be a real game changer. So this means that anyone can use the GPU that's in my system and pay me for it. One of the blocking things for businesses doing that is the ability to keep their models private and keep their data private. So keeping a model private would mean when you are building your model, which is obviously like a hugely intensive task, you don't want someone stealing it and like walking off with it because it's running on some random person's computer. But being able to train private models, which is something we can achieve through zero knowledge, which is another area of crypto, basically will enable us to train these models, not reveal those models, but still use that hardware, and then bring that value back to us. Private data is then the extension of that, where both the model and the data you're training it with are private. And this can be done to some extent today, but there are some costs to it. It's like half as fast and things like that. But over time, these things will become more efficient. So this is a really, really important way for us to get rid of the kind of gatekeepers on the side of compute. Talent, I'll leave that up to you. I don't think that crypto has a great solution to this right now. I wish I did, and if I did, I'd probably be a very rich man, but there you go. So really, in summary, by connecting blockchains with AI, with this verifiable data, this decentralized compute, I think that we can build like some really impressive stuff. And with a vision like DeepIn, decentralized infrastructure coming along, where sensors and other things be integrated, we can start to represent more real-world use cases into crypto. So yeah, thank you very much. I'm happy to take any questions.
Okay.
Could you explain that? I mean, I understand that this is a great talk and a great vision. I like it. But could you explain once more to me that I understand this verifiability property once you have this blockchain infrastructure in place, but there is still a step where you need to put the data on the blockchain. Say you mentioned sensors, for instance, or you would put something from the real outside world. And as anything, it could be a property or pollution values. And in this process, you still have some manipulation issues that cannot be solved by the blockchain. So you would like push some of the problems to a different place, but they do not go away automatically. Or do I misunderstand that?
Yeah, I think, so basically it's about like, how do you know that those sensors aren't just lying? How do you know it's not just me typing in the value? Yeah.
If you're very paranoid, they could
yeah.
have a mindset for it.
Sure. So I think in this case, there's a few different ways. So sensor diversity, so you would have sensors provided by different companies. You'd also want signed hardware and software, which would mean that you can't run arbitrary software on there that's open source and verifiable. So when I buy one of these sensors, you can cryptographically prove that you've not been modified. And also you can do like tamper-proof resistance and stuff. Of course, there are always ways around these things, like ultimately with enough incentive. But if you've got 30 people running, let's say, 3 different types of hardware, I think it's going to be very difficult for people to kind of go and fake that. So as an example, like say one building has 30 pollution sensors in it, like the likelihood of all of them lying, and bearing in mind there's an economic incentive not to lie as well, because if you're caught fiddling your pollution sensor, you'll get slashed, which means that they take your money, right, because you've lied, and everyone else told something else. So now you've got to manipulate a lot of people, you've got to manipulate hardware, you've got to get around things like TPMs and other security features. So I think the answer to your question is, can you do it to the ultimate extent where it's 100%? No, like that's impossible for any kind of platform, but can we kind of game theoretically make it extremely unpleasant to do that and basically not profitable? I think so.
Thank you.
More than welcome.
Still have time for...
Thank you. Sounds like the answer is very similar to proof of work and how decentralization and 51% attacks were prevented on Bitcoin. But I wanted to ask, we saw that the opportunity is vast. Where does Superchain actually fit in? And how are you helping to facilitate either one of these? Well, talent, I presume no, but you can't offer that, but the other things.
Sure. Thank you very much, my good plant. Superchain, basically, blockchain data is actually really difficult to use, and if you've ever tried to use crypto, you'll know what I mean. But in particular, history and getting things like really real-time, like really snappy user experiences is currently horrible. We basically take all of the chains, at the moment ones that are similar in type to Ethereum, and make that data really easy to use. But at the same time, we don't break the trust that comes with Ethereum, so we have a way of basically doing that which keeps the data trusted, transparent, etc. So we're building the Open Index protocol to do that, which will be launching next year as a fully decentralized network.
Okay, thank you, James, very much for the inspiring talk.